All right, let's do this. Chapter 8 test review for Math 2. For each graph below, list the domain and range in behavior, x and y intercepts, and any extrema. If there are none, write none. Okay, so let's look at this first one right here. What's the local min? Well, we see a local min right here, and notice it's going down by 2 each time. 2, -4, -6, -8. So in between would be -9. So we know that's the point 0, -9. Is there a local max? No, there's none. It just goes up forever on both sides. No local maximum. What is the domain? Well, notice how that's going forever left a little bit. It's kind of curved. It's going forever right. So our domain is our x values, right? And it's all real numbers. Or all x. What's our range? Well, our range is going up forever, but it really starts here at -9. So it's y is greater than or equal to -9. What are our x-intercepts? Okay, let's look. We see one right here. We see one right here. That looks to be the point -3, because, right, they're still growing by 2 each time, and it looks right in between. And this one looks like 3. Now we want to look at the end behavior. As x approaches negative, oh, you can't see it. Let me move it up. As x approaches negative infinity, so it's going left. What is y doing? Y is going up and up and up. So y is approaching positive infinity. And the end behavior over here, as x approaches positive infinity, what is y doing? It's still going up, approaching positive infinity. And I realized I missed my y-intercept. But guess what? My y-intercept is the same as my local min, which is 0, -9. I did miss that. Okay, perfect. Let's keep rolling. Looking at this one right here, I see extreme points here, here, and here. Okay, and I'm assuming this is a scale of 1. Nothing says anything, so we'll call this a scale of 1, 2, right, 3, 4. Those would be negative, I guess. And then 1, 2, 3, and 4. All right, we're just assuming it's a normal scale. What's the local min going to be at then? Well, if this is 1, 2, 3, 4, 5, 6, 7, 8. That'd be 7.5. All right. So I see a local minimum at -1. That's -5. 6, 7.5. -1. -7.5. I see another local min right in the middle here. Actually, it's kind of right there. We're just going to guesstimate it. I'm going to say that's almost like 0.3, right? As long as we're close, it's good. We're just giving a guess. And what's that point right there? It's at the point x equals 3.3. And the y value is like -1, -2, like -2.8, -2.7, somewhere around there. So -2.8. We're really just guessing, aren't we? That's fine. If it tells us to give a guess, we'll do it to our best of our ability. And then the local maximum, that looks to be right in the middle of the box itself. So what is that going to be? That's going to be 1.5 and up 0.5. That would be a local max. Now keep in mind, this is the actual minimum. All right, domain and range. Let's look at domain. Again, it's going up, but at a slant, still a slant this way, so x is still all real numbers. My range, I got to go down to my minimum, my absolute minimum right here, which we estimated to be -7.5. So we're going to say y has to be greater than or equal to -7.5. What are the intercepts? Well, let's look. We see one at -2. I see another x-intercept at 1, 0. Another x-intercept at 2, 0. And another at 4, 0. There's 4 x-intercepts. My goodness. And then our y-intercept we see right here at -4. So that'd be 0. Oh, you can't see that. Sorry. 0, -4. And last but not least, as x approaches negative infinity, this is still going up. So that's approaching, y is approaching positive infinity. And as x approaches positive infinity at the end here, what's happening? Right, in behavior, we see it still going up to positive infinity. So the end behavior was identical between the two, right? Because again, we ignore what's happening in the middle. We just look at the left and right side, and we can even see when we cover it up, it looks similar. Okay. Let's go ahead for each of the graphs below, decide whether they are continuous or discrete. Also, list if they are linear or nonlinear. Well, right here, let's scoot the screen up. This looks like it makes a line. However, it's discrete. So discrete. Goodness gracious, I don't learn how to spell. And what is it though? It's linear. It is a line. I can put a ruler down, and it would hit all the points. There we see that. All right, let's look right here. This is continuous. It flows. There's no breaks, nothing. Perfect. So this is continuous, but it is not a straight line. Clearly, my ruler is not going to hit every point with that, so it is non-linear. Speaking of that, let's look down below at these ones. Anything past the first power is non-linear. Absolute value x, that actually makes a V shape. It is non-linear. Right here, that's y equals mx plus b form. That is linear. A lot of people might think this isn't, but remember, I can pull that 5/3 out to make it y equals 5/3 x minus 2. That is linear. That's point slope. It's linear. All right, again, pause if you need to. This is just page 1. Oop, I don't know what's happening. The graph shows the height of a ball in feet per 1 second or t seconds after being thrown. All right. So A, what is the maximum height the ball reached? Well, looks like it's right about here. Again, since each of these is going up by 2, I'm going to guess 15. So 15 feet. How long was the ball in the air? Well, it came down here. That looks at about 1.8 seconds. So I would say about 1.8 seconds. Looks good. Okay. What is this one? Draw a sketch of a graph that is linear, has a y-intercept at 0, -3, and as x approaches infinity, y approaches infinity. Well, this could be a lot of graphs, guys. Basically, we just need to draw a line with a positive slope. Remember, it takes 2 points to define a line, so that would work. That would work. Really, any line that goes through this point has a positive slope, and we'll meet that need. So, there's that. All right. You only need to draw one example of it, but there's many you could have drawn. Graph the following linear equations. Okay, let's do it. Start value, -4. Slope can be written over 1. 2 over 1 means up 2 over 1, and I like to do it a couple times. Label your x, label your y, because we do that. Draw a line all the way through, put arrows on the end, and label it. Y equals 2x minus 4. Boosh. Absorb that in. It's amazing. Okay, let's look at this one right here. Again, start value positive 2 this time. And the 1/2 tells me to go up 1 over 2. Up 1 over 2. Oh, I got the yawns tonight, y'all. It's evening. line. Arrows on the end. Ooh, I didn't mark down my x and my y. Do you need to label it? Y equals 1/2 x plus 2. Okay, there you go. Select the correct equation for each graph below. All right. First of all, it's a dashed line. It's dashed when it's greater than or less than, which means, it could be any of those. Now, if I put my pen on the line and I go up, we drew in the upper boundary, which means it's greater than, so y is greater than. So we're down to either B or D. And then let's just see, what's our start value? Our start value is at 1, 2, 3, 4. Which one of these has a 4 start value? That's 3, that's 4. It has to be D. And just to prove it from here, if you go down 1, 2, 3, and over 1, look, you're on the next point. Down 1, 2, 3, and over 1. That is how it works. So it's y is greater than negative 3x plus 4. All right, let's look at this one. Solid line. Solid line means it has to be greater than or equal to. So it's either B, or not greater than, but it's an or equal to. So it's B or D. We're going up from the line to get into the shaded region. Therefore, the shaded region is in the greater than or equal to section. We know it's greater than or equal to because I had to go up to get there. But wait, that's it? That's it. Y is greater than or equal to negative 6 plus 8. Which, let's see, from this point right here, I can go 1, 2, 3, 4, 5, 6, and over 1. And we see that it matches right up on the line. All right, awesome. You guys are amazing. That's the end of the test, or test review. So write good notes. I would say draw some of these graphs on your notes. Do an amazing job. Peace out.